Okay, so you know how it is in the AI world, right? It's
Yeah,
like
yeah.
every week there's some new
Yeah.
big thing that drops.
Yeah.
And this week it's like, oh my gosh, Meta just like, they threw down the gauntlet. They dropped LLaMA 4,
Yeah.
LLaMA 4. Like, this is not just an incremental upgrade or like a little, oh, we made it slightly better. This is like,
Yeah.
it feels like a paradigm shift.
It's early days, but yeah, the early reports are just incredibly exciting.
Hmm.
Really suggests like a real breakthrough,
Yeah.
particularly in terms of like overcoming some of the kind of, I don't know, limitations that we've kind of accepted with these large language models. So
Right.
it really makes you rethink like what's actually possible.
Yeah, exactly. And the thing is, this isn't just some like abstract tech thing, you know? For you listening to this actually has the potential to like really fundamentally change how you interact with information and how you think.
Right.
Like imagine having an AI that can truly grasp like massive amounts of data. Like think entire libraries, and then give you like actionable insights in moments, you know?
Totally.
It's really incredible. So today what we want to do is we want to kind of cut through the hype and really dive into what makes LLaMA 4 so significant.
Right.
And what the real world impact could be, especially for you listening, you know?
Yeah, and it's a fascinating story.
Yeah.
And it's unfolding quickly. Just when you think the pace of AI development can't get any faster, something like this comes along.
Right.
And it kind of resets expectations.
Yeah. And one of the first things when you start reading about this that jumps out, it's like the context window.
Yeah.
100 million tokens. I mean,
Right.
First of all, for those of us who aren't, you know, swimming in AI jargon all day, what exactly is a token in this context?
Right.
And why is 100 million such a jaw-dropping number?
So you can think of tokens as kind of like the fundamental units of language that an AI is processing. You know, a very loose analogy would be like parts of words or something like that.
Okay.
So when we say 100 million tokens, that means that this AI can hold and process the equivalent of
Wow.
literally like hundreds of books worth of information in its immediate memory.
Yeah.
While it's understanding and responding to you.
Yeah.
To put that in perspective, you know, leading models up until recently, we were talking about context windows that were, you know, in the low millions.
Right.
So this is an order of magnitude larger.
Yeah, an order of magnitude.
Yeah.
So like instead of feeding an AI like a chapter at a time, you could potentially give it like an entire series of books and then ask it like nuanced questions about like character development or like plot inconsistencies, right?
Yeah.
I mean, that's crazy.
Totally.
That's a level of deep understanding that we just haven't seen before.
Yeah, precisely. It allows the AI to kind of maintain context and coherence across these incredibly long and complex inputs, which is, you know, that's something that has been a real hurdle previously.
Yeah, yeah. And the thing is, it's not even just one like super powered model. It's not like they just, you know, went all in on one thing. They announced this whole family, right?
No, right.
So you have the small one, which is Scout,
Scout.
and then the medium is Maverick. Then there's large, and then there's this future behemoth called BEMO.
Right.
Like it sounds like they're really aiming to like cover a wide range of applications with this, right?
Yeah, and I think, you know, that kind of tiered approach is quite strategic, right? It suggests that they have different use cases and performance targets in mind for each of these models.
Right.
But what I think is particularly exciting is that the initial three, Scout, Maverick, and Large, they're all natively multimodal.
Multimodal. Okay, so that means that they can understand and work with not just text, but like different kinds of data.
Totally. Yeah.
So we're talking images.
Right.
And potentially audio and video down the line. That's what it means.
Yeah. Okay. Okay. It's really moving towards AI that can interact with the world a bit more like we do, you know?
Yeah.
Like processing information from these various sources simultaneously.
Right. Right.
So, you know, you could imagine an AI that can analyze a document.
Yeah.
But also understand the images that are embedded within it.
Right.
And even process like a linked video. All, you know, all is part of the same stream of information.
Wow. Okay. Okay. So let's dive a little bit deeper into how these models are actually built because, you know, reading through these reports, they talk about something called mixture of experts architecture.
Yeah.
And it's phrased in a way that's like it's not a thinking model in the, you know, traditional sense, at least not yet, you know.
Right.
So can you break down like what does that actually mean?
You know, The best way to think about a mixture of experts model is it's not like one giant brain that's trying to do everything. It's more like a team of specialists.
Yeah,
right?
okay.
It's composed of lots of smaller submodels, or what we call experts.
Right.
And each of these is kind of highly skilled in a particular area.
Got it.
So you might have, one expert that's really good at math.
Yeah.
You might have another one that's a great creative writer. Another one's amazing at coding, and so on.
Right, right.
Right.
So then when you ask it a question, it's almost like it figures out, okay, which specialist or maybe combination of specialists is like best equipped to answer this question.
Exactly, yeah.
Yeah.
There's a kind of a smaller internal mechanism which acts a bit like a router.
Okay.
It kind of directs your query to the most relevant
Got it.
expert or group of experts.
Okay, that makes sense. So what are we talking about in terms of like numbers here? Like how many of these experts are we talking about?
Right. So the numbers are they're pretty big. So LLaMA 4 Scout has 109 billion total parameters.
Wow.
But only about 17 billion of those are actually actively engaged for any given task.
Okay.
And those are spread across 16 different experts.
Okay.
Now, Maverick jumps up to 400 billion total parameters.
Wow.
Again, with about 17 billion active.
Okay.
But this time distributed across 128 experts.
Right. Okay. And then BEMO is...
In the BEMO, that's the really big one.
The big one, yeah.
2 trillion.
2 trillion?
Total parameters.
I mean, it's hard to even imagine.
It is, yeah.
The scale of that 2 trillion.
It's hard to conceptualize.
But let's go back to Scout for a second.
Okay.
Because we were talking about that 10 million token context window, right?
Right.
Which is what, like a 5-fold increase over
It is, yeah.
over what we've been seeing recently.
Yeah, it's a huge jump.
So why is that such a monumental leap forward?
So that context window is essentially the AI's working memory, right? It dictates how much information the model can keep in mind.
Right.
While it's processing your request.
Yeah.
And then generating a response to you.
Got it.
So the larger that context window, the more the AI can kind of understand longer narratives, complex instructions, and maintain coherence across these vast amounts of data without getting lost.
Right. Right.
Essentially.
And there are even reports that meta engineers are hinting at a future with a quasi-infinite context window. I mean, it sounds almost unbelievable.
Yeah, it really does.
But the trend is clear, right? Like overcoming the limitations of the context window is like a major focus of development.
Totally.
So imagine a world where you can feed an AI like entire research papers, years of financial reports, massive code bases, and it can like understand the intricate connections and nuances throughout.
Precise.
I mean, right now it's like you kind of have to chop things up into smaller pieces, and you potentially lose vital context in the process.
Yeah.
This could be a game changer.
Yeah, it really suggests that you could just give the AI the information.
Right.
And it can just work with it directly, potentially reducing the need for all this extensive kind of pre-training on every specific topic.
Right, right. So instead of needing a model that's specifically trained on, like, ancient Roman history, you could potentially feed it like a comprehensive history of Rome, and then
they'd be good to go. Yeah.
Wow, that's amazing. So when you look at how LLaMA 4 performs against some of the current like top contenders, the reports are pretty striking.
Like, oh, yeah.
Like Scout is supposedly the best multimodal model in its class,
right? Based
on active parameters, right? And it's outperforming even larger models like Gemini 2.0 Pro and Mistral.
Yeah.
So what does that tell us?
I think it really highlights the power of this mixture of experts architecture, right?
Right.
So by having these specialized components, they can achieve this kind of top-tier performance.
Yeah.
But while using a smaller number of actively used parameters compared to more traditional, like, dense models, Right. So it's about working smarter, not just bigger.
Right.
And then Maverick, which is like the medium-sized model, it's reportedly beating GPT-4, Gemini 2.0 Pro,
right? Yeah,
and others in key areas like reasoning and coding.
Yeah,
and it's doing it with significantly fewer active parameters than some of its rivals.
It is. Yeah,
that's a pretty bold statement.
It's a big claim. Yeah. But, the independent LLM Arena rankings seem to corroborate this,
Right.
Gemini 2.0 Pro was holding that top spot, but LLaMA 4 Maverick has surged to number 2.
Wow.
So, it really is outperforming some of the biggest names in the field.
Yeah, that's pretty amazing. And then here's a point that I think is going to resonate with a lot of people. LLaMA 4 Maverick is open source. Right.
So the model weights are freely available, meaning anyone can download it, use it, and even tinker with it. I mean, that's
massive, yeah.
huge deal for innovation.
Yeah, it's a real game changer, right?
Yeah.
Because, open sourcing allows researchers, developers, hobbyists even around the globe to experiment with it, build new applications, and contribute to the evolution of this technology.
Right.
It fosters a much more collaborative and kind of, rapid pace of advancement compared to the closed-off proprietary models.
Right. Okay, so let's talk about this teacher model.
The mode, yeah.
Which is the massive one with 2 trillion parameters that isn't publicly available yet.
Right.
It's being used to train the smaller LLaMA 4 models through something called model distillation.
Right.
So what's the benefit of that approach?
Okay, so think of it like you've got this world-renowned chef,
Okay.
and they're training a group of sous chefs.
Right.
So BEMO, having been trained on this enormous data set,
Right.
possesses all this vast knowledge and these sophisticated capabilities.
Yeah.
So through distillation, it can actually transfer some of that expertise and those advanced skills
Right.
to the smaller, more efficient Maverick and Scout models.
Oh, okay. Got it. So this suggests that, we could see even more powerful and kind of refined versions of those models in the future, inheriting some of BEMO's kind of cutting-edge abilities.
Okay. And apparently BEMO itself is said to outperform some of the most advanced models currently available. So
it is, which kind of that gives you a sense of the potential there, right?
Right. So, Meta's decision to go with this mixture of experts architecture.
Right.
It seems interesting, especially when you consider that there's a lot of focus on building AI that can think more like humans.
Yeah. It's a really interesting choice.
Yeah. So why might they have chosen this path? So I think it's kind of a strategic trade-off, right?
Okay.
So while the pursuit of kind of general thinking AI is ongoing,
right,
the mixture of experts approach offers significant kind of practical advantages right now in terms of scalability, efficiency, and this kind of potential for integrating more advanced reasoning later down the line.
Okay.
So there has been some discussion about using techniques like reinforcement learning to potentially add more complex reasoning capabilities to LLaMA 4 in the future, leveraging this kind of efficient architecture.
So it's almost like they're building a really strong and efficient foundation now that can then be built upon with more advanced cognitive abilities down the line?
It seems that way, yeah. It allows them to deploy these highly capable models in the near term, but also keep the door open for future advancements in reasoning.
Right, okay. Can you give us like a really simple, like everyday analogy for how this mixture of experts system actually works when you give it a prompt?
Sure. So imagine you've got this really complex question.
Okay.
And it requires expertise in several different fields, right?
Right.
So instead of asking one person who might have some general knowledge, you've actually got a team of specialists, right?
Got it.
So you got a doctor, a lawyer, an engineer.
Yeah.
You direct your question to the team.
Right.
And then there's a coordinator there who quickly figures out which specialist or combination of specialists is best suited to kind of address different parts of your query.
Right.
They then work together to provide a comprehensive answer.
Okay.
That's essentially how a mixture of experts model works.
Okay, that makes perfect sense. Now, one of the really compelling aspects of this announcement seems to be the reported cost efficiency of LLaMA 4.
Right. Yeah.
Like, it's supposedly significantly cheaper to run than models like ChatGPT-4.
It is, yeah.
So why is that such a critical factor?
So cost is a huge barrier to the widespread adoption of powerful AI, right?
Yeah.
So if running these models is prohibitively expensive, then their real-world applications are going to be limited to a select few.
Right.
So the fact that Meta has reportedly achieved this significant reduction in inference costs while maintaining or even exceeding performance benchmarks
Right.
makes LLaMA 4 incredibly attractive
Oh, okay.
for a much broader range of users,
Yeah.
from individual developers to large enterprises.
Right, right.
So it kind of democratizes access in a very real way.
Yeah, and the figures are pretty stark, right?
They are, yeah.
Like something like 19 to 49 cents per million tokens
Right.
for LLaMA 4 compared to, several dollars for some of the competitors.
Yeah, exactly.
I mean, that kind of difference could really open up
It could, yeah.
a lot of new possibilities.
Yeah, it could change the economics of these AI-powered applications.
Right.
And really make them viable for a much wider array of use cases.
Right, right. Okay, so finally, let's go back to that incredible 10 million token context window.
Okay.
Because the reports mentioned something called a needle in a haystack test.
Right, yeah.
To really demonstrate its power. So
Right.
first of all, what is that?
Okay, so the needle in a haystack test, it's kind of a clever way to evaluate
Okay.
how well a language model can retrieve very specific
Right.
buried information from within a massive amount of text.
Right.
So imagine hiding a single sentence,
Okay.
the needle,
Yeah.
within thousands and thousands of pages,
Yeah.
the haystack.
Right, got it.
And then you ask the AI
Yeah.
to find that specific sentence.
Right.
So a larger, more effective context window
Right.
should allow the model to pinpoint that information accurately,
Yeah.
even when it's surrounded by this vast amount of kind of irrelevant data.
Okay, so, and how did LLaMA 4 do?
So the results were really impressive. So whereas a model with a smaller context window might struggle,
Right.
or even fail to find the needle as that haystack grows larger,
Right.
LLaMA 4 Scout, with its 10 million token capacity,
Yeah.
was able to retrieve that specific information accurately,
Okay.
even when it was buried within this enormous amount of irrelevant text. So it really showcases the power of that extended memory.
It can actually find that one specific piece of information in that ocean of data.
It can, yeah. It's amazing.
That's astonishing. And they even tested it with like a 20-hour video.
They did, yeah.
And apparently LLaMA 4 Scout could recall specific details from that video
Yeah.
with only a couple of minor errors.
Yeah, that's a truly remarkable feat, right? To
Yeah.
be able to process and retain information from something as long and complex as a 20-hour video
Right.
really highlights the potential for AI to understand and analyze very long-form content.
Right, right.
Opening up possibilities we've only just begun to explore.
So when you put it all together, I mean, yeah, LLaMA 4 feels like more than just an incremental step forward.
It does, yeah.
The sheer size of the context window,
Yeah.
the multimodal capabilities, the efficiency of the architecture,
Yeah.
and then the open source aspect of it.
Yeah.
It all points to like a significant
Yeah.
leap in AI capability.
It does, without a doubt.
Yeah.
It really addresses some of the fundamental challenges that have kind of limited the practical applications of these large language models.
Right.
Particularly in dealing with these vast amounts of information in a cost-effective way.
And for you listening, I mean, really think about this. The ability to process and understand truly massive amounts of data
Yeah.
quickly and affordably.
Yeah.
Like, how could that change your work, the
Yeah.
way you learn, your access to knowledge?
Right.
I mean, what new questions could you even begin to ask
Yeah.
with this kind of power at your fingertips?
It really does force us to consider what becomes possible when AI can truly absorb and synthesize information
Yeah.
at this kind of scale.
Yeah.
What new discoveries might be made?
Yeah.
What new solutions might we find to complex problems
Right.
when we can leverage this kind of information processing power?
It really feels like we're on the verge of something truly transformative.
It does.
So if this deep dive into LLaMA 4 has sparked your curiosity as much as it has ours,
Yeah.
we encourage you to really think about the implications of this. What specific applications come to your mind?
Yeah.
I mean, this feels like just the beginning
It does.
of a really fascinating
Totally.
new chapter in the world of AI.
A whole new era.
Yeah.